Welcome to the session. In this session, we'll be discussing about transformer. Transformer is a very useful electrical device and it is frequently needed to use it in various electronic circuits. So in this session, we will understand what is the transformer and what is the basic principle on which transformer works and how this device is suitable in order to transform the energy from one location to another location or from one point in the circuit to another point in the circuit. So let us start the session with the question what we mean by transformer. Transformer, as I said, it is a device, and to this device we will apply a voltage, input voltage, and normally the voltage that is being applied to the device is the AC voltage. So this voltage can be a high AC voltage, and this device can convert this high AC voltage into a low AC voltage. But it doesn't mean that every time we need to convert a high AC into low AC. It is also possible that you can convert a low AC voltage into a high AC output. So transformer can do both of the things. It can transform the input high voltage into low AC voltage, or the input low AC voltage into a high AC voltage. Transformer has no moving parts, internal moving parts. It will transfer the energy from one circuit to another circuit, and while making the transfer of the energy, it will make the use of electromagnetic induction. So transformer works on the principle of electromagnetic induction. So as shown in this diagram, you will find that there is some core over here and the coil is being wound. This is to be called as a primary coil, and another coil is wound on the core, and this is to be called as a secondary coil. So whenever the transformer increases the voltage, then that transformer can be called as a step-up transformer. When the transformer reduces the output voltage or decreases the output voltage, then that can be called as a step-down transformer. Transformer transfer electrical energy from one point in the circuit to another point in the circuit. And the advantage of using transformer is that it is completely insulated from each other. So with the help of the transformer, it is possible to use very high voltages for transmission lines, which can result in a low current. And high voltage and low current will reduce the required size and cost of the transmission line, and it will also reduce the transmission loss. So transformers have made us possible that it is possible that we can deliver the electrical energy in a very economic way, and the delivery of the energy can be made over the long distances. So let us understand what is the principle of operation of the transformer. The transformer basically works on the principle that the electrical energy can be transferred by the magnetic induction from one circuit to another circuit. So as I said, the transformer has a primary coil, the transformer has a secondary coil, and these two coils are kept very close to each other. They are wound on the same core. So when the current is allowed to pass through the primary coil, then it will produce the magnetic induction, which is being called as a flux. And when another coil is kept in the close proximity of the first coil, then the voltage will get induced into the another coil or the secondary coil. So the amount of the voltage that will be induced in the secondary will be same as the voltage across the each term of the primary winding. So if we increase the number of the turns of the coil, then the voltage induced in the secondary will be more. If we reduce the number of turns in the secondary, then the voltage induced will be less. So if the secondary has more number of turns, then the voltage induced in the secondary will be more, and such a transformer can be called as a step-up transformer. And if the voltage induced in the secondary is less, then such a transformer is to be called as a step-down transformer. So it is possible that we can calculate the energy that is being transferred, and we can calculate the efficiency of the transformer. Suppose we have a primary coil, the number of turns are Np. We have a secondary coil, the number of turns are Ns. Suppose the voltage is applied to the primary coil and voltage will get induced into the secondary coil. Then in that case we can define a ratio called as the turns ratio, which is Ns upon Np. And if Vp is the primary voltage and Vs is the secondary voltage, then Vs upon Vp is equal to Ns upon Np. So one can easily understand, if Ns is greater than Np, then it is a step-up transformer case. If Ns is less than Np, then it is a step-down transformer case. And if you assume there is a zero loss in the transformer, then the power in the secondary windings will be equal to that of power in the primary winding, and therefore Vs into Is is equal to Vp into Ip, or we can write Ip upon Is is equal to Vs upon Vp. And therefore we can calculate the efficiency as power output divided by power input, and if you multiply it by 100%, then we will get the percentage of efficiency. So one can easily observe that the current ratio, and it is the inverse of the voltage ratio, that is the voltage set up in the secondary, step up in the secondary means the current will step down, and vice versa. And the efficiency can be defined as the ratio of the output power to the input power, and by using this formula we can calculate the efficiency of the transformer. So thank you friends for viewing the session. Hopefully you have understood the basic principle of the transformer.